Hello everyone. Today we will be discussing how to implement SVM, that is support vector machine, and k nearest neighbor, another classifier, on a simple dataset freely available in Kaggle called as iris dataset, for which we need to know or we need to be familiar with the features for the dataset at first. Let's go to the link. You can go to simply Google and type for iris dataset Kaggle. You can find a screen like this. Now this dataset is actually about identifying flowers, and for this particular dataset three types of flowers have been considered. So we have to identify a flower using some features of it. First column in this dataset is about the ID of the sample. Second one is the sepal length in centimeter. The third one is sepal width in centimeter. The fourth one is petal length centimeter. Fifth one is the petal width centimeter, and the last one, that is actually the target variable, actually which discusses about the name of the flower, or in this case particularly 0, 1 and 2 will be used to represent three names. So the species is the last column, which will be telling us the type of the flower, that means the which flower we want to distinguish from others, so that will be denoted by species column. So let's have a look at this data set. ID column, sepal length, sepal width, petal length, petal width and species respectively are the columns. And here we can see that three types of flower actually have been considered. Now the setosa is the first category of the color. Setosa is the first type of flower. Second one is the versicolor, and the third one is the virginica. Now for these three types of flowers, 0, 1 and 2 will be used respectively as the values of the target level, that is the species column. Now if we just want to run SVM, that is the simplest classifier we can say. So from sklearn.datasets import load iris, that is actually preloaded in the sklearn package. So if we want to import in our particular notebook, for this I am using Colab, Google Colab. For that you may go to the colab.research.google.com. there you have to sign in with your Google account, and after that you can see this type of a notebook. You have to create a new notebook, and after that the cell by cell running will take place. So from sklearn.datasets import load iris, and then in the iris variable we are just loading the iris dataset. Actually the dataset is called iris, so iris equal to load iris. Now we have to specify in the dataset which are the independent variables and which are the dependent variable. Now just suppose a situation where y equal to fx means y is a function of x. So that means y is a variable which is dependent on x. X is independent and y is dependent. Now for this particular dataset, what we can say is, depending on the sepal length in centimeter, sepal width of centimeter, petal length in centimeter and petal width of centimeter, we can specify the species of the flower. So here these four and the id also. Apart from id, what we can say is sepal length, sepal width, petal length and petal width. These four are the independent variables and species is the dependent variable which is dependent on this particular four features. Now for that we need to specify x as the independent ones and the y as the dependent ones. So actually, as you know, the for array concept, the indexing starts from 0. So 0 is the id, sepal length is the 1, sepal width is the 2. So after that petal length and petal width we will consider only. So 2 and 3 will be considered in our case as the data. That means we are just omitting the sepal length and sepal width. We are just considering petal length and petal width to determine the species. So this is the x and y is the target. That means this one is the target. So y will be the dependent one. So iris dot target is the y. Now if I want to place the entire data into a pandas data frame, I am not going into that much depth for the data frame concept. We will be knowing it later. Just what I am saying is we have to import the pandas, and if I just want to call it with a shorter name, then I can use this type of syntax like import pandas as PD. That means from now onwards the pandas will be called as PD. Wherever we will be mentioning PD, that will be meaning that we need to mention pandas over there. So iris underscore data frame, df is the data frame. So iris underscore df, we are naming it like that, and pd dot data frame is all about the data from second and third column and the feature names starting from second column. Now if I just after running this particular cell, if I just go to the next cell, iris underscore def dot shape. So iris data frame, this one, for this if I want to see the shape, what is its shape? So 150 comma 2, that means 150 rows are there and 2 columns are there. What are these? The 2 columns are the petal length and petal width. So if I just want to see the shape of this iris underscore df, then this type of syntax can be implemented, and after that I'll be seeing the shape of the iris df. Now if I just want to print the first 5 rows of iris underscore df, then I can do that by print iris df dot head. This head actually results in returning the 5 rows, first 5 rows of the data frame, whatever I am supplying as its argument. So iris underscore def dot head, that will return the first 5 rows of the data set, and it will print using the print command. Now import numpy as np. Numpy is a package which is used for numerical calculations in your data set. So import numpy, and here also like pandas we used pd, here also we are using np as the shorter form of numpy. So import numpy as np, and then the unique labels. Here we already have seen that the labels are 0, 1 and 2 for each and every class respectively. So the unique labels in this data are str np dot unique y. So for each and every unique value of y, the unique labels will be printed as 0, 1 and 2. Now we have to split the entire data set into training and testing. So xtrain, at first the train test split has been the train test split function has been imported from the sklearn model selection module, and then 4 variables xtrain, xtest, ytrain and ytest. We already have been familiar with x and y. Now those x and y, both of them will be splitted by training and testing. So it will be partitioned into two portions. One is training and one is for testing. So x train y x test and y train y test. Then train test split function is called, for which the first variable is the x, then the second argument is y. Then we have to specify the test size. Here we have used 0.3, that means 30% of the entire dataset will be considered as the testing data, and the rest of the dataset, that means the 70% dataset will be used as the training dataset. So test size 0.3. Now just after running this cell, if I just see what is the shape of the x train, then I can see that 105 rows, and in the test portion there are 45 rows. So the 150 rows have been divided into training, that is the 70% of it, and testing, that means 45 rows, that means the 30% of the entire dataset has been called as test. Now if I just want to print like this, that there are this much samples in the training set and this much samples in the test set, so that we can do is as the x train dot shape, as this is an array, so the first value if I want to print, then this type of indexing should be used, and x test dot shape, this type of indexing should be used. And after that, if I want to run svm on that, so at first we have to call the standard scalar function, and here we have named the object with sc, and then we have to fit the x train portion on that sc. So sc dot fit x train. Now if I need to standardize my features, then x train underscore std, and this transform function can be called to standardize this x train, that means the features of this x train. So x train underscore std will be the standardized form of x train portion, and the x test underscore std will be the standardized form of x test portion. And after standardizing the features, the first 5 rows, if I see, if I want to print like the previous case, here the petal length and petal width of the 5 samples, of the first 5 samples, first 5 rows of our data now looks like this. Now if I want to just plot the 3 class data points, so for that we have to as we will be using the color maps, so here we have to import the listed color map module from the matplotlib.colors, and for the plotting purpose, whatever we are plotting over here, for the plotting purpose we have to import the pyplot from the matplotlib package, and here we have named it, this pyplot we have named in a shorter form called as plt. The markers will be S, X and O. That means these are the S. Here we can see X type of marker, X shaped marker rather we would say, and O, that means the round shaped markers. And for the 3 types of classes, the colors will be red, blue and light green respectively. Here you can change it according to your preference, no problem with that. And after that the C map has been used, that means the color map has been used, and after that for each and every unique value of y, the x values, y values have been plotted using this scatter function, that means the scatter type of plot will be there, and cmap and marker type. Here we have initialized the markers objects and colors objects, so those are just being called over here, and the plotting has been done. That means the class, the each and every data point for each and every class is now scattered like this. Now the fitting part, we want to fit our SVM model on the standardized X-train dataset. So here at first the model building part in this line, here the kernel has been considered as the radial basis function. The random state is 0 and gamma is 0.10. These values actually can be varied. This gamma, C, kernel, these are the actually parameters of SVM, and we can vary it. If I want to increase the performance of my model, then I can manually vary it, or I can use some predefined functions of Python like random search or grid search. You can go through that later on. So here just manual model building has been done. So kernel RBF, random state 0, gamma 0.1 and C 1.0. So these are the values which I have particularly set for my model, and SVC has been the function for which the parameter values have been the arguments. Now after building the model, I just want to fit the X train and Y train. So X train standardized form and Y train has been fitted. Now after fitting, if I just want to see the accuracy, so for that the score function can be used, and xtrain underscore std and ytrain, that means this is the training data accuracy. And if I just want to see the classifiers accuracy for the test data, I'll be using the same variables just for the test. That means here the change will be reflected. So after 0.2, that means 0.95. So after the decimal point, if I want to just see two numbers, two digits, then 0.2f out of 1. So this is the print statement, and here this will be replaced by the svm.score. That means whatever this svm.score is returning, whatever this score function is returning, that will be replacing this 0.2f, and that will result in this type of output, because after applying RBF kernel and 0.10 gamma and 1.0 C, here we can see that the accuracy of the SVM on training data has been 0.95, and the accuracy of the same for the testing data is 0.98. Now if I just want to plot the decision regions, and if I just want to print the X test standardized form and Y test using the SVM model we have already built, then the plotting looks like this. Now if I do the same thing using the KNN classifier, here almost though everything has been done before the just building the classifier. So X, Y, shape finding out part, then the train test split part, almost everything has been done. Now just we have to build the KNN classifier like this. Here we have built the SVM classifier model, here we have to build the KNN. So KNN, then K neighbors classifier, this particular function has to be used as we used SVC like for the SVM. Here we have to use K neighbors classifier. Before that we have to import that from the sklearn.neighbors package, and then we have to specify the values of the parameters. So n numbers, that means the number of neighbors will be 5, and p is another parameter which you can go through later on. What are the functions of it, how does it work, so you can go through later on. So after applying the K neighbors classifier, we have to pass the values of the parameters for it. So n numbers, p and metric, as the parameters have been passed, and after that, like the SVM, here also the fit function has been called to fit my model. This KNN already has been built, so just fit the X train standard and Y train onto it. So KNN dot fit, and then two parameters. Then after that, like the previous case, here if I want to just see the accuracy of the KNN classifier, whatever I have built with these parameters, if I just want to see the score, that means the accuracy score, in that case KNN dot score, like the previous case, here also score function will be used, and before that the model name has to be specified. And for the training purpose, for seeing the training accuracy, here we will be supplying the training variables, and here we will be supplying the testing variables, X test standardized and Y test for the seeing the accuracy of test data. So this is the thing. And now after that, if I just plot decision regions, we can see that here some misclassified points are there. For the red part, there are no misclassified points, like no blue has come over here, no red has come over here. So red has been classified perfectly, but for this part here we can see this one green point has been a little bit collided, and here this blue point, whereas it should be here in this blue region, but it has gone into the green region. So here we can say that there is a little bit misclassification. Among this number of points, only two misclassified points are there, but there has happened misclassification. So for that we saw this 0.98 out of 1. That means 2% of the data points have been misclassified. So 0.98 out of 1. But here what we can see is the line is not rigid at all. The hyperplane, if I see, this has classified the points very perfectly. Here in the blue region only the blue points are there, and in the green region only the green points are there. So it has perfectly classified all the data points. So this accuracy of this particular test data has been 1. So that's it. If you have any kind of doubt, you can ask.